Alright, so you're given a copy of this truss. So I am not going to keep it inside a frame. I'm going to more or less keep my work inside of there. I'm going to make this one continuous video. I'm not going to re-record it, so if I'm making mistakes, hopefully I don't. That's the way it is. I will try to slow down and look at that. I'm going to go moments first, then A, B, C, and then probably D to solve this truss. So I'm going to scoot this up. I'm going to grab myself a pen and some paper, and I am going to get to work on solving this. So again, you have your own picture of this, so as I scoot it up, I'm not too worried about keeping you happy to be able to see it. I'm going to let you see my work here. So I've got moments. I've got to go off of my pen. So I've got at D, I have a moment at D plus a moment at C needs to equal the moment at B. So D has a distance of 2. So I've got force of 100 times the distance at 2, plus I've got a moment at C, which is 1, 2, 3, 4, 5, 6, 7, 8. So I have a force of 300 times 8, and that needs to equal my distance of 9 times my reaction force at pin B in the Y direction times my 9. So I'm going to grab out my calculator. Don't need a calculator. What am I doing? I've got 200 plus 2400 is equal to 9 RBY. So I've got 2600 equals 9 times RBY. Just to make sure I do this right, I am going to grab my calculator for this one. 2600 divided by 9 gives me 288.8. So I'm just going to round that up to 290. I'm just going to use 290. So RBY equals 290. Our number is going to be a little bit off going through, but I don't like writing extra numbers. I'm just trying to save myself here. So at the roller, I've got reaction force at pin B in the Y direction equal to, not 900, that's where I'm getting lazy, 290. So, all together now, on my picture, I had at D, I've got 100 down. At C, I've got 300 down. At B, I've got 290 up. So therefore at A, I need 110 up. So I'm going to go over here. A, reaction force at pin A in the Y direction needs to equal to 110. So that's what I got so far. So now I'm going to go in my free body diagram at joint A. So where should we go here? We got room. We will keep it right here. So we're going to go to joint A. So free body diagram. I've got a pin sitting there. So I had the reaction force at A in the Y direction we just solved was 110. I have got a member here. So I've got the force acting upon the member of AE. That is in the X direction, and I don't know its value. And then I have the force of member AD. That one is diagonal. Anytime I got diagonal, I've got the two composite, 1x, 1y. So I have the force of AD in the y equals, I don't know. And I have force of AD in the x, also don't know. So I've got three things to solve for. I've got to try to solve for this triangle. I've got to solve for the sum of all the forces in the x equals 0, and the sum of all the force in the y equals 0. So what do I know? Triangle, 3 unknowns. The only thing I do know about my triangle from my original picture, that this is 56.31 degrees. X's, I have 2 unknowns. Y, I have 2 y's, one I know, one I don't know. This y needs to be 110 going down. 110 going up, 110 going down. So from there, I know I'm compression. I've got to go down and to the left, so I've got to calculate FDX. So I know this is 110. I've got to find that x value right there, and I need to find the hypotenuse. So this is FDA, and this is FDAX. x. So if I want FDAX, that's adjacent. Let's do the hypotenuse first. We'll do sine. We've been used to doing that one. So now I've got the sine of my 56.31 equal to the opposite of 110 divided by FDA. So multiply FD over and divide. I've got FDA is equal to 110 divided by the sine of 56.31. Grab my calculator. I got 110 divided by